Hey, welcome to Coffee Compiler Club. Here today to talk about compilers and language runtimes. Everyone's been recorded. We show up on YouTube in an hour, well, or three or four or five. Um, no set agenda. It's whatever people want to talk about. Today I'll talk about I'm implementing smart contracts for HBAR Hedera, which is another language implementation, but one that's has to take into account finite resources, including finite amounts of time. And it's just a very, I'll say, naively designed virtual machine that's targeted for running smart contracts. Some decisions were made that I would certainly have never made that make it difficult to get the contract to run fast, which if you're running millions a second, you kind of want the code to run reasonably fast. So there's that piece. At the moment, it's a dumbass interpreter.
Quick question. I thought you were working on Mojo.
I did, and after about 3 months, Mojo and I decided that I was not having a good time and not feeling very helpful. So it's sort of like oil and water don't mix. It's Cliff and LLVM don't mix well. I can talk about things that didn't work. Um, the biggest
You,
one is C++ is very, very slow these days. Back when I used it, when I coded in Anger doing hotspot, so year 2000s, um, code generation on C++ was, it remained high quality code gen. Um, when you ran in debug mode, the code ran 2 to 3 times slower than optimized, which was acceptable. And compilations in optimized mode were reasonably quick. Fast forward 20 odd years, and my machine is 100 times faster. My C++ compiles are 100 times slower, okay, 10 times slower. And the generated debug mode code is also 10 times slower, despite having the machine be 100 times faster. So what the hell happened? Well, C++ got into this templates or everything which are implemented as inlining, and in debug mode, nothing actually inlines. So you just drown the death of endless function call and returns in debug mode. And when you're compiling a bigger project, it takes a long time, 5 minutes to compile and get set up to run in the debugger, and then the debugger's slow, so it's 10 minutes to get to your bug. Or you're running in optimized mode, then it's 5 minutes to build, and you get to your bug within a minute or 30 seconds, and you have an optimized build, and you're debugging with printf statements, which take 5 minutes to go get the next printf, to change a printf and go again. So it's like a really tedious development environment. Um, the tooling wasn't so great either for like go find things or show me the hierarchy of the code paths through here, find the whoever's after you dive through all the templates. Um, that shit works better in Java for whatever reason. So very slow development cycle times. Everyone there present lived it for so long they thought it was normal. And I've lived with cycle times that edit, compile, debug are always under a minute, generally under a few seconds. My own personal projects, they're always well under a fraction of a second. I use the compiler to go find the next syntax error because I just edit and hit a button and then it's a compiler error and I'm at the next syntax error. So there's never a I hardly need the thing that says, and here's your spelling on your code or whatever, the highlighting for incorrect. I don't care. I just hit the go again and compiler stops me at the next syntax error. Okay, fine. At the Hedera project, it's about a minute to compile or get to a bug, and in both cases. So I'll look a little time. I won't just hit the compile button every second. Um, but it's down from 5 minutes. That's like a huge difference. And then the dev tools are just easier to deal with. So I did some stuff with them. I had a lot of there's some there were some miscommunicated expectations that went on as well. I thought I had a particular mandate that got hard no yanked when I came in the door. Like the guy who hired me basically said, "You're going to do this." And I said, "Okay, cool, I can do that." And then I walked in the door and said, "Nope, you're doing that." And I'm like, "Oh, that sucked." So betwixt those two, it wasn't fun, and I wasn't making a lot of productivity, wasn't making a lot of progress. So I bailed, and they were happy to see me go, and I was happy to leave. So it was mutual, and I'm off Mojo.
You
And
lasted longer than I did with him.
I'm sorry.
I, I interviewed for your job in 2005,
Oh, there you go.
but you lasted longer than me.
Oh, wow. Okay, fine. I put a good effort in. It wasn't working.
You know,
Um,
Cliff,
I
I,
really
I
like working with the Hashgraph folks. I don't know if HBAR succeeds or fails. They've been around longer. They're one of the longer lived um, Bitcoiny things, and it's a lot more fun. I'm actually doing something, so I'm having a good time. I'm getting paid for it. I'm working Bitcoin. Well,
Cliff,
HBAR.
I have a feeling that this is the start of your journey towards becoming eventually a Rust developer. Uh, I'm also in the crypto industry, and obviously everyone is like kind of deep into Rust, so it doesn't take many steps. Give it a year or two, and
I see. Yeah, leave a thumbs down, right. Yeah, my opinion on Rust is it's backed by LLVM, so it's automatically too slow a development tool.
yeah,
I
true.
have garbage collection. I don't need Rust's memory management, and I'm
In,
fast enough with garbage collection.
in
So,
fairness, Rust has a very wide set of configurable passes that you can choose from. You don't have to do the O2 pass that they come preloaded with. You could do something a little simpler.
it could
And
be, could be. So,
even debug, like even the fastest configuration, debug plus fastest linker or whatever on a beefy machine is just like, I mean, personally, I think even then it's like soul crushingly slow
yes.
on
The
larger
the
projects.
linker, the linker, yes, the linker's bad, but the compiler's not that slow.
Were you
I,
able
but
to
it's also
get
slow.
were you able to get precompiled headers and you know, work uh
You mean
out
you mean
outside of templates?
no? I took whatever best best efforts they had already involved in to get good compiles out, and it wasn't fast by any means.
Oh, C++ modules, not yet. They're not there.
No, no.
There's
So you had to pound include all the headers. Yes,
mm,
right. Exactly. So, anything that I would want to have as a development tool had better have some reasonably fast mode for doing development work. That's just a thing. You just got to get the bugs out before you can get the thing to run fast. It doesn't matter, it goes fast if it's wrong.
Yeah, I think the solution that I have to that is a 64 core Threadripper machine.
Yeah, but that still doesn't
I'm
make
rooting
the
for
the
CPP front.
the common problem or the common thing was edit one file, compile it, link it, and run. That was 5 minutes. The one file would be 2 minutes on one core. The extra 63 cores didn't do you anything. And that's C++ pound including 100,000, a million lines, a huge amount of pound includes that it just has to punch through. And then, like I said, you had your options of a little bit faster if you were going to go to put out a debug, or a little slower if you're going to put out. Oh, yeah, Levo, I didn't hear you there. It had been working, Levo, your mic, and your mic, you're not muted, but fine. Anyhow, it was
One
just gruesomely slow.
The only thing about C++ that I will not defend is the compilation speed.
Yeah.
That's like
Well, yeah.
my least
It's
favorite
like
part about it.
So IBM did a bunch of programmer productivity tests, and human nature hasn't changed much in the last 30, 40 years. And their answer was sort of very obviously, um, if the turnaround time between you hit a key and you saw an action was under a tenth second, it was too quick for the human eye, you didn't care, you didn't know. The difference between a microsecond and a millisecond was invisible, so no one cared. The difference between a tenth second and like most of a second was, about the same as you just kind of like paused it in your head. And that worked up to about 2 seconds. You kept your short-term memory alive and you kept your focus, and the problem came back at you and you could go again immediately. Past 2 seconds, you started to drop short-term memory and focus, and you were beginning to drift into things about lunch and my back's a little sore and I need to move my foot and scratch that itch, whatever. And you took another couple seconds to get back into the flow and go again. Past about 2 minutes, you got up to go to the bathroom and get a coffee, and then you had a coffee break discussion with somebody about blah blah blah. And past the 2 minute mark, like your productivity drops off really hard because you just completely get out of the flow. So in my head, there's like a definite stiff curve, and I feel it too. There's a definite stiff productivity drop off. If you're after 2 minutes, you suck. It's soul crushing, what Adrian just said. I agree. And if you're under 2 seconds, it's pretty good. And somewhere between 2 seconds and 2 minutes, you have the it's okay versus it's not okay. I can wait for it or I not or whatever.
One of the things I've been working on. Oh,
Oh, you
well,
have
that's a lot
terrible
of
echo
echo.
now, Ryan.
That's not mine. I'm
Okay, that's
using a
better.
headset.
That's better.
One of the things that I was working on was trying to make single file compilation basically multi-threaded for incremental compiles.
I managed to get that to work. Oh, my microphone works too. Great.
Yes, your microphone works too. So it's like I want my single file compilation to be fast, but my experience with I don't know what languages people are working on here with most of these languages is you can make a fast single threaded compile if you're not pound including the world. If you have module like things, you have some way to get the headers, you can make a single file execution be fast enough, compilation, single file compilation, fast enough that I don't need to go multi-threaded. It's hard to get good performance out of multi-threaded without sort of making, I want to say, fake test cases or starting from a language that you didn't want to start from.
I got a few things to say before I forget all of it. At the beginning, I heard from Microsoft that if it's 200 milliseconds, people feel like it's instant, and
Yeah, it could
that
be 200 values. I think I said 10, but 200, something. Yeah, yeah.
yeah, I heard it like if a click is 200 milliseconds or less, that people like it. I notice sometimes when I click on something, I don't actually see a change, even though because it was like so quick.
Right.
So
Yeah.
uh, I know that C++ can be multi-threaded by having multiple processes and not actually like threads. But
But that's parallel make, like pmake works.
yeah,
That's
yeah,
a single file per core, but many files go to many cores. But if you only have one file, you only get one core.
yeah. I think I also noticed that every compiler does not do anything multi-threaded except for Go, but Go is actually really slow. Like, like
I,
I think the original one was supposed to be fast, the one that was written in C, but Go written in Go it's not fast.
Go is actually really fast to compile. I can say that with a high degree of confidence, compared to C++
How many
at least.
yeah,
how
Go has
many
no
lines?
excuse not to be fast. It's a very simple language. It should compile quickly.
How many lines though? Like what are you compiling?
Stuff we compile. I mean, part of it's probably the fact that it caches some stuff, but if I'm compiling something in Google 3, it's got lots of dependencies, and it still compiles in under a couple seconds.
Okay, that would be reasonable. Like, and the trick here is to say I had to change something, so I changed a file, and then I got it running within a couple seconds.
Yeah, I mean, I don't know how long, honestly, like it would take to compile if you redid everything from scratch, but at least the caching and stuff works well enough that.
Yeah, but caching works for C and C++ too. That's not the question.
Actually, C++, the caching is terrible because you change
Okay.
one header file and then you have to change
Yes.
12 compilation units, and each of those takes way too long to compile.
Okay. Yeah, yeah. So C++ has the header. If you change the CPP, you get one file. You change a
It
header, and in
it
the
still
recent
doesn't
cases I
cache
worked
very
on,
well
it would
though,
be
because like in C++, like if I change a file, it recompiles all the stuff in the headers that haven't changed. That is such a because like
It,
even the precompiled headers, it's not really fully precompiling them. Like it's only kind of precompiling them.
gets the parsing, some sort of parsing pieces done.
Yeah, yeah, it's not doing everything. And that's like one of the things that I want to be able to do is like I'm in my language design, I'm aggressively caching stuff to the point where like things are cached, which like you'd say, oh, well, why would you do a map lookup for that operation? That's going to be so slow rather than just, um, like recalculating it. And it probably is. But my logic here is like at some point, if I'm aggressive enough with caching things, the majority of things will be cached between compilations and not like invalidated.
Mm.
And even if I change a file, if I can have like bits of the file that are cached and not have to recompile the whole file, maybe that will end up causing me to not have to redo work between, when I change a file.
Oh,
Like the initial compile might be super slow because I'm caching all these individual pieces.
there it goes.
But if I change it and I have
Yeah.
a node that has a dependency and I like track which things have
Right.
changes that propagate through them and then invalidate bits that where the inputs changed. And then those nodes would recalculate, and if they produce the same output, then it stops. Because like you could have a node that's got some
Yeah.
set of inputs, right, in your previous cached result, and then you change the file node, right, and then you change this AST node, and then you change something that uses that node, and then if the result it produces with the changed version is exactly the same as it was before, it stops propagating, and then you're done with your compilation.
Okay. I'm slightly different. Anything for me that's doing node manipulations that came out of whatever I would parse for is already too fast. The caching will lose to just do the math. However, once I've crossed a parsing boundary, so I'm in different modules or different
Yeah.
files,
So
then
so
I definitely want to cache.
Yeah, what I call a node is like very abstract because like a node could be like, what is the IR for this function? Like
Okay,
that's
fine.
that's a node. Like anything
Yeah.
that has a like for me a node is like something. It's like a question. So I call these questions, and they're like it's like the node has like a resolver, which is like okay, what is the function IR? Like that's like function IR resolver is a node resolver, and then the node itself is like that in combination with the input parameter, which is like, okay, here's the actual function. And so that is a node inside the graph,
Yeah, fine.
essentially, of all the dependencies of the program. And so these exist like there's a single entity of that node that can only be calculated once in each program compilation. So like if I ask what is the
Yeah, right.
size of this class, right? Like what is the size of this class is going to query another node that's like what are the fields of this class? And then there's what's the abstract syntax of
I
that
mean,
module.
I certainly cache all the typing things. So size of class and fields in class and the like, those are all
Ryan, in your
pre-computed.
language, do you need to see the body of a function to understand the signature?
Um so no, because there are some asterisks here because like if the function return type is auto, it will have to dig into the signature to
Right.
find the return statement and then figure out what the return type is. Um,
That's what I'm doing with simple. Everything's an auto return, so I have to dig in to know what the return is.
but
Okay,
as
because
as
in my language, I made sure that I can figure out all the signatures without looking at the bodies, and that's how I made everything multi-threaded because I could just have all the threads look through all the files, and I mean not all the files, all of the files they're processing, collect the function signatures, and then it will. There's like a barrier that makes sure everyone is done with that. Then there's like the main thread just does like a quick
It-
thing. It does it incrementally, and then it says go, and then all the threads just compiles everything, and it's like it's
It's
really
doing it
fast.
function by function.
Yeah,
so
yeah.
in, my compiler is based on the idea that there is a solver, right? And I haven't actually added the multi-threaded version, but the basic principle is that if everything is a pure function that takes inputs and then produces an output, and it's not, and it's basically just a pure functional, like it's not actually functional programming because like inside the node it might be, using imperative patterns, but like as far as like it takes some input data that's read-only, and then it produces an output value, right? Those you can have more than one of those calculations running in parallel because the inputs are all read-only. So you can have as many of those running in parallel as you want, as long as you know what more than one of your dependency is at the same time. And so the solver is just
So
there's
if in the realm of I have to dig in to get auto return sorted, when you dig in, you hit another function who's also an auto return, and your return depends on his return. You have to recursively keep digging,
yep.
right?
So that could happen. Yes. I haven't actually implemented auto return yet, but basically
Oh, I
that
see.
would it will so
Well, it's fine. I can
I could
I see
show
what
you
you're talking
how.
about. If you can delineate a region where you know things, and then you can keep other threads from getting in this region, and things you do get from getting out, then that region can be optimized by itself, whatever that means.
Okay.
And function call boundaries are an obvious one, and signatures make an obvious border, and now you can do all your functions in parallel.
Here, let me
Although
copy and paste
do you,
something in.
do you deal with inlining? What do you do about inlining?
It's the bug builds only, so I don't have to deal with that.
Okay.
I figured that when I get to that part, it will just be
I got different
completely
goals.
separate thing, and it doesn't even matter because like if you're in line, if I'm optimizing, it probably doesn't matter how long it takes. I know
Point
your
out.
experience is
Well done.
bad, so I guess I would need an O1, an O2, and then maybe an
That
O5.
was the Java. That was the big Java learning for me. The compile is fast, and it does optimized, and it does debug, and that combination is really sweet.
There's actually a couple things about C++ I wanted to say. I'm going to forget later, but I heard a story. Okay, so there's a guy named John Lakos. He works at Bloomberg. He mentioned in his talk that he wants to make a C++ compiler. But when I contacted him, it turns out the idea is so they can prototype new C++ features. He did not, and then eventually get the prototypes into
Right.
existing compilers, namely LLVM.
Right.
And I was extremely disappointed because he's not trying to solve the compile times, the bug issue, or any of that stuff.
Right.
So I sent him a few emails, but yeah, I was so disappointed.
You know, it is what it is. That makes a lot of sense. If you're a big trading banker and you have, high frequency, whatever, high fast algorithms for doing fast trading things, and you're trying to get some cool hack in, these guys are like ideal candidates for trying to push the borders of what's in the language. They have
It,
money motivation, they have money to go deal and produce a prototype and go check it out, and then they're willing to live with without it being in the main language because they have their own private build for it. But then, if it gets upstreamed, then that's great. I'm not at all surprised that's how it goes. I'd be more surprised if they're trying to solve the overall C++ problem of fast compile and fast bug both at the same time.
I
Where's
thought
Matt
that
when you
fast
need him? He has
iteration,
more to say about that one.
I thought fast cycle times or iteration would be very important
Well,
to that, but I guess
what
not.
has what
Both.
has changed since like semantic C++ was literally, 10th of a second, build for a small directory of files in C++.
Templates.
Templates.
Templates. Yeah,
Oh,
templates.
we had STL back then. It was
It,
still
when I
pretty
It's
good.
when I started on Hotspot, STL was not yet there. Now, when I left Hotspot, STL was just barely coming along. And at the time that we were building Hotspot, the we had to survive on a bunch of compilers on a bunch of OSs, and different compilers did different bad things with templates. So the intersection of templates that you could use that were well done by all the targets that we had was like square bracket operator lookups for dictionaries or growable arrays.
yeah, I can
Anything
even
else, just you ran one C plus or another, blew out horrible C front, blew out horrible piles of code for templates. And it wasn't worth debugging, and performance sucked and it wasn't worth it.
We
So
went
if
to
bad performance and
town.
bad debugging, don't do it.
Well, like
Hard to
Borland had it. Borland had what preceded C++, and G++ had a library.
yeah.
We went to town, and it was probably a smaller scale than today, but um, Okay.
We had some compilers could do reasonable things with templates. Some could, but not all of them. Like we were compiling on Solaris and we were compiling on Windows, DOS, and we were compiling on Mac, and we were compiling on a couple flavors of Linux. And these were targeting 6 to 8 CPUs at any given time because that was, Java write once, run anywhere. And one set or another couldn't deal well with this kind of template pattern or that. So as a team, as a whole, we made a
Are,
decision. This sucked. Don't bother.
are we talking about the template like compile time performance or the runtime performance though?
Yeah, both. Frequent and the developer experience. So it's a combination. One was the compile times on some platforms for templates would just blow out. Sometimes the compiler would just crash. That was a fairly common in the early days of templates. Sometimes it was fine, except that if you had an error in the template, the error message was 1,000 lines of pukage,
Oh yeah, we
no
still have
fucking
that one.
code, right? So those were all things that were sort of like your developer experience sucks. Now, sometimes the generated code was bad and I mean, slow and it was no performance. Like the whole point of the templates was saying, hey, I got to use a small byte int shorty thing as the key in a hash table, so I didn't have to have a giant hash table that took an indirection layer for keys and values or whatever. Except that whole goal of that was to run faster. And if it ran slower, what the fuck, right?
Well, I don't know about older compilers, but as far as modern ones, templates in the compiled binary, templates,
Yeah,
modern compilers perform amazingly well.
yeah, yeah.
Compilation
Nowadays,
time,
right? We
compilation time, not so good.
we came in at the threshold of templates and STL, and it was not a reliable thing. Now, when I left, certain uses of templates we could now use reliably, but we weren't going to go back and rewrite the code to use them. And then in the years afterwards, 15 years afterwards, they all got cleaned up and they do reasonably well things. Except in debug, then you got to this tension we're at now, where in debug mode they don't inline. So the debugger experience is much, much slower than it was so many years ago with no templates. Like if I went back to the code that I was looking at that was very template heavy, got rid of all the templates, the debug experience would probably be the same as it was 20 years ago. It'd have been 3x
I,
slower, not 10x slower. And that'd be a lot, actually be a
I
lot.
I would say that it's a little bit less of a problem now because the branch predictors are a little bit better at handling those indirections than they used to be, relatively speaking.
It's just you blew out with I suspect they're actually blowing out iCache. Like every call and return and the predictors work well. And they worked pretty well back then too. They had them back then for a call and return, stack predictor. Um, but there's so much of it. It's just drowning it.
Oh
And then
yeah,
you iCache gets overwhelmed.
I
So
remember last year there's a picture in the Discord about how the branch predictor is as big as the L1 cache. That's insane.
it, there's a reason.
yeah. Branch predictors are pretty nice now. Um, I could actually talk about some of the things that slow the reason why templates have gotten so much slower because I've dealt with this in my own project and I've consciously chosen to do things in my own project that have made compilation a lot slower because they add convenience for like the development side of things. And sometimes I'm regretting this. Like for example, like all of so like when I have my like graph type, right? Like I put each sort of resolver type inside the graph structure of like there's like a big object which is called the compiler, but that contains all of the different like indexes for each of the different types of nodes that would be in the graph. Because like
Okay, don't
and
go too deep into the details here. That you were
right.
saying, hey, I now regret because, and the because is
Well, what
oh
I
the
could have
compile.
done, right? What I could have done is I could have instead of putting each individual type of index inside the struct and having its own like structure, I could have just did dynamic typing. And then if I did dynamic typing with the nodes, there would be one extra runtime lookup when it's like, okay, I want a node and here's the type of the node that I want, and then I have to do an extra indirection to find like because I would have not only like the key to it, but also the type right? I would have to like serialize it and have like a string, or like I want this type of node and make that a runtime variable, and then I want this is the input to it, and that's also like a runtime variable. But the
Yeah,
way
I'm
I have it
not, yeah, it's
now,
okay. I'm not following without seeing the pattern you're trying to
okay,
implement.
so like what I'm doing now is like the type of the node that I'm requesting is a compile time,
When
just
you say
like
request, what does that mean?
uh,
Like if I'm in
let me go.
C,
Okay,
I see what's
go to
supposed to
go to.
say new add node.
All right, look at the doc and go to the first example. I have like I copy and pasted some code into here. This is one of my actual resolver implementations. This is this one's still in progress, but it works. And so this one is the class layout resolver. And I do need to fix this to sort the fields, but because this is not the way that they're supposed to be ordered. But what this does is so the actual like so you can see this co-await thing here, which is like
Yeah.
I have a dependency on something else in the graph, and it is a class. It is a type of like class field list, and it's parameterized with this input, which is going to be okay. This is the class I want the layout of. So in order to figure out the layout, I need to know what the class is and its fields. So I have a dependency on the class field list. This class field list is not a runtime parameter. This is just like this is compiled in. It knows where the class field list index is, and that's statically typed. And because that's statically typed, every time I add an additional type of resolver, it has to recompile every single resolver implementation function. Because if I add a type of resolver, this struct is like this is statically known at compile time. Like it knows where the index is that does this input. Like the only thing that it's actually doing a tree lookup on is the input class. It's not like class field list
Uh,
and the input class. So
I have no such. I'm not following why you're coming out from here because I have no such dependency in anything I'm doing for class layouts.
so like what I'm saying is like I have the compiler. So each of these nodes, right? It needs to know what the layout of the compiler is to know what the index of the or like the offset of the index into that compiler
Yeah,
structure
right,
is.
right.
So every time I add a field to the compiler, everything that depends has to recompile.
Okay, so back up for a second. You're adding into a field in your user's program that you're compiling. Are you self-compiled? Is that your
Oh,
self?
I'm just talking about I'm not compiling the compiler, not the performance of the runtime, the compiler at runtime. So like,
Oh, if you're
um,
compiling a compiler. Yeah, again, why do you when you compile a compiler, don't you compile it in C++ plus plus and the C++ plus plus deals?
yeah, I'm saying that it's slow in C++ because like if I change anything in the compiler, it has to recompile almost all the translation units because every index that references the
Right.
compiler has
I'm trying to figure
to.
out where you get the connection. Like as soon as you say I have to do for all class fields in the compilers, you say class fields here. It's kind of highlighted. That's class fields in the compiler implementation.
Right. So, but what I meant is like,
I'm asking a question. Is that what that means? As opposed to class fields in the thing being compiled.
so class field is a structure that is used inside my compiler to represent like the thing the compiler is compiling. Um,
Okay.
like so class field
So class
contains.
fields,
So
I
is
wrote
it
a
fair
simple
to me
program
to
that
think of this as a struct that has been embedded in a very large number of other structs? So every time you add a field to
yeah,
this struct, you have to recalculate all of the
yeah.
other structs because all those structs embed this struct rather than, say,
That's
a
what I'm
pointer to it.
confused about. But yeah, that makes sense. Like certainly
Uh,
I'm not doing it that way. I have an
so
array of field layout and offsets that I fill in lazily when I need it. Like I don't compute offsets until I'm near the end of compilation, but then one touch, I go to a class and say, you have fields, name, rank, and serial number. What are their offsets? And then they
yeah.
lazily
Do you mind if I screen share for a second? This would be easier than copy and pasting all of this. Um,
Um, yeah, let me find just a second here. Example in the doc, that's your comment. I have to.
The trick is that they move permissions every time you have to click it.
Yeah, I have to, right. I have to deal with, yes. I have, it's moved again here. Hang on. Okay, try now.
Allow and this one. There you go. Let me know if you can see it.
Yeah.
Okay. So like, um, so here's like these are resolver implementations, right? And then I have my. I should probably put this in here as well.
Yeah, I'm not clear what a resolver is. This is a
So
field layout.
so think of it like a pure function, but everything it's almost like a pure function, except it is number one, it's using a bunch of coroutines, so there's all that junk. It keeps track of its dependencies, and so like if there's an in like this thing gets automatically added to a list of dependencies, and there's like a graph that's created.
Right, right. You're not answering the question directly. So I'm reading the output here, and it looks like you're computing field layouts for a
Yes,
structure.
that is exactly what this resolver implementation does.
Okay.
Um,
And why would there be more than one of these?
okay,
You have every
this is like the processing function, but like the class layout, there's one class layout resolver per compiler or like index, but then like there is like a cache. So each
no, back up,
class,
back up, back up. Do you have in my head, you have one piece of code given a class structure of some kind, he computes field layouts. Okay, so then you say for all classes, compute a field layout when it's time to compute field layouts. So there's just this one wad of code, and it's being called for all classes. And indeed, you have for all fields here to do your field layout. But this piece of code in my head gets called once for every class object in the user
right?
program under compilation.
Yeah, basically, yes. So like
Okay.
this is how these are used. Like these this is also like class field list is also the same kind of one of these implementation defs. So like this is like saying go grab the node that is class field list with this input, which is going to be the class name in this case. Or the
Okay.
right. And so I guess the the thing that I was actually trying to bring up here is the reason why this
Yeah,
will
why do you
compile really slow
why is this slow?
is like if I
Uh,
go into this compiler here, right? So here's the compiler. So
Yeah.
this is a bunch of indexes, right? And this means that it knows at compile time where the offset of each of these indexes is, and it doesn't have to do like it doesn't have to include the type in the runtime lookup. Because like for
Yeah,
example,
I'm
as
really
the
confused here because I certainly
like
don't have anything. I don't need anything like this in any compiler I've ever done. So I don't understand where this is coming from.
okay, so like you see these class layout, class
Yeah.
field list, class
Right.
tags,
Yeah.
right? So each of these contains a cache. So if I have a function that's like, okay, what is the class layout of foo class?
Right.
Before it runs, it's not going to immediately like, it's not going to go and it's not going to, where did I go? It's not going to run this. What it's going to first do is it's going to take that input and it's going to look in a tree and it's going to see, have I already calculated the class layout for this class? If yes, it's just going to return the already calculated result because there's an index.
I
Like
got
it's
you. So why do it? Why put the cache somewhere else? In the class object itself, you just have a field layout, which in my version of things is it's actually a type, not the class, but it's similar. Fine. The field layout is just an empty field that when it gets filled in, you've filled the cache. And when I come to a class and I say, give me your layout, first thing it says is, do I have one? Yes, here you go. Else, compute. And then here you go. And it's done lazily and it's done with one body of code and there's no template instantiation or there's no replication in every little thing. It's just,
yeah, I've this approach. The reason I like this is that everything like this is there's no there's no class struct because everything is like functionally pure, right? So there's inputs and there's outputs of each node. So I can't have a something that contains the class because that would require mutation.
okay, so you're now you've declared yourself. I'm going to set myself a problem that's not necessary and proclaim that it's all functional. And now I have to have a cache somewhere else, but I have to have a cache anyhow. So I have mutation. That's the cache. I just put it outside the thing instead of inside the thing.
Right, but it means that these are all functionally pure. And like I can
Okay.
therefore do things that I like there's certain guarantees about like a functionally pure
Yeah,
like I can run them all in parallel. And there's no
yeah.
like, oh, did I lock this? Did I not lock this? Is there a multi-threading
Right. Your
bug
cache
or
has
like
to deal with the concurrent updates, but
yes, but
yeah,
that's implemented once. And
yeah,
then
right.
as
Yeah,
long
yeah.
as that's correct, it's correct
Okay.
everywhere.
I claim that you'll have trouble beating me on performance for this kind of stuff because the overhead of updating the cache atomically is almost surely going to start to exceed the cost of an if check that's just done once and filled in.
Well,
But you didn't say you were doing it for performance reasons. You said you're doing it for developer niceness
Which,
reasons,
yeah, I
right?
don't get either, which is fine. Maybe I don't. So
well,
your head
well,
and my head work differently here.
both. Well, you also have to look up your class object, right?
I don't come to the field layout until somebody had a class in their hand, and they wanted to ask a field layout question. So there's no
Right.
lookup in that sense. Like I'm in code generation and I've had an abstract field offset all along, and suddenly I'm done with field with whatever optimization. I actually need a real field layout. So somebody says, well, give me the offset for field X and person object or field name. And I have the class in hand because that's what I had at the point. And then he's, both pieces, the name and the field. Well, the name is not a name. It's already just the class structure itself. And the field offset's actually, it is in fact the name at the moment, but it could be an enum. I don't care. And then I go into the class and say, do you have a layout? No. Yes, you do. Okay. Give me the field X's offset. And that will just be find the field and that'll have a number 248, 16, whatever the offset is. And I can show you the code that computes that and show you the code that uses it, but it's all done on demand when somebody has a class in hand. So I don't have to look up the class. I had the class in hand.
Right. Well, I don't pass around like a reference to a class object. I just pass around like the class symbol. So like
Yeah.
module foo colon
When I
colon
okay,
bar.
In your
That's
language, is there a concept of get attribute by name,
you talking to Cliff or Ryan?
Ryan?
so like
Like I can say a dot field name, the compiler can replace that with a fixed offset. But if I say a dot get field for name, here's a string, then all those names and offsets have to exist at runtime in the binary somewhere.
well, I will have a const expr implementation of that at some time, but it won't be something you would do at runtime. So like there is const expr evaluation, for example, like
So it's fine for your field names to boil away into field offsets as you're compiling.
yeah, so like let me see if I can find an example of this.
Ryan, your answer just made me think your language is going to be way bigger than mine and take a lot longer to implement.
It probably will. But like here's an example. So for example, 3 plus foobar.
Can I
Uh,
can I just interject 1 second? So, Cliff, I would believe that you probably at your profession with this new crypto company are looking at the exact same language that Ryan in his imagination has come up with.
I am looking at the Ethereum spec for executing Ethereum bytecodes. There's a
Oh, the
well-documented,
Ethereum
well-understood
VM is
spec.
so much slower than it needs to be.
Absolutely. And HBAR is using the Ethereum spec so we can run Ethereum contracts. So there's not a competition in the coin space for people writing contracts for different platforms. I totally get why. Now, is that spec fast to execute? I mean, could it? Yeah, minor things could have been done. You're correct, Aaron. Minor things could have been done in the definition of the spec to make it much quicker to execute. Holy shit balls. So there's some work to be done to make it execute fast. Fine.
I
And
mean, in the
things,
early days, they pushed the exact opposite. There were discussions when they were just creating EVM at the very beginning of like, does this need to be a general purpose programming
yeah,
platform? And they're like, our contracts are going to be like, if enough money in account, do transfer.
right. Yeah,
If you're
yeah.
never going to have a program that's more than 20 instructions long, who cares
I-
how long it takes to run the instructions?
oh, I
Well,
see. No, right. And then these
all
days
the
they're doing like bad crypto hashing in the Ethereum contract language, not as an
Yeah, now they want to
intrinsic.
calculate Mandelbrot's in the VM. It's fine.
Yeah, right. It's like, holy crap, guys.
contract languages gravitate towards optimal and hmm,
Oh,
use some Haskell.
EVM portfolio. No, no, Adrian, it's the other way around. I have a giant mountain of productivity ahead of me. I got my shovel and I'm going to start cleaning out the Aegean stables and it will be so much better when it's done.
Are
And
they
I'll feel
trying to
very
push this
productive
stuff
while
into
I'm
the general
laying down.
EVM or?
Well, Adrian in the chat saying, "Oh, poor Cliff, EVM. Yeah, it sucks." On the other hand,
That's a
there's
that's a really great attitude. I mean, every time my stock portfolio crashes, I always say like, there's so much room for growth.
yes,
So
exactly, exactly.
Aaron's like argument, I think this is something that irks me a bit because yes, you could make maybe in the first phases of designing the VM, you could have people saying, okay, we're not going to use this for something critical, but it's not like it takes much effort to just make it a bit more efficient.
It was,
This,
the
right?
story I hear was like a couple of 18, 19-year-olds, and they did something
Yeah,
sort of mathy, reasonable, but had no VM definition experience.
the
Mm.
first version of JavaScript was hacked together from an implementation of, Scheme, I think.
Ah,
He
okay,
started with Scheme, hacked it into JavaScript, stuffed it into the browser, and
right,
got that done in less than a month.
right. I get it.
Google's crankshaft optimization was an amazing amount of effort to make JavaScript performant. I
Right.
think there were real benefits in the early days of EVM to say now is better than good. They
Right.
needed out something out the door.
I can't believe
And
this
But
knows.
the
Like,
world has changed. We've now reached to the point where good is better than now, and it's worth taking 6 months to really improve the EVM that
but you can't go
is
back.
being used as a meaningful application platform.
You can't go back and rewrite all the contracts, and that's the problem, right? You have to
I
live
mean,
with
the V8 team wasn't able to rewrite JavaScript.
exactly.
I
So,
mean, they did. They called it
but
Dart. It wasn't popular, but that's fine.
oh, well, I didn't know
Yeah.
was that's where Dart came from. Oh, that's fine.
yeah, Darts from my memory didn't like when I tried to run it, it would just produce several megs of JavaScript. I can't remember, but it was pretty bad.
Producing Elm was producing JavaScript at a high volume. They
Yeah, I don't
claimed
know if
it
people
was
have connections,
perfect.
but we should definitely get someone from the Dart team to come talk to this club about why they did things in Dart differently than JavaScript in their belief that that would make the VM more efficient.
Sure, but like the belief was they could take over JavaScript at some point. Somebody had to believe they could take over JavaScript.
I have a topic change for Cliff, if you
Uh-oh.
want it.
Yeah, right. Go ahead.
Okay, so I'm just thinking about code generation, how much exceptions make code bigger, and what's your opinion on exceptions and exceptions in Java?
Uh-oh,
Like,
they don't.
would you even like Java if there was no exceptions?
So separate questions. The like Java, no exceptions is a different one. Kind of depends what everything else, like the holistic view of what the other alternative Java would look like. Exceptions serve a real purpose. You can live without them, but there's actually reasons to have them, and so you usually end up with something. And in a large language that actually survives to become popular, you usually have some effective exception-like behavior. So saying I'm not going to have any doesn't make sense. Almost surely you will, or you won't be popular. All right, now, what do they cost? They cost very little in Java. They probably will cost very little in any language that does the same kind of things that I was doing. Um,
Isn't there going to be like some weirdness about optimizing because you have to make sure that like if anything can throw, then how do you
right.
make sure you don't mutate
I
variables or
did it
not?
all the time. And so the answer was I threw in every safety check as normal control flow. And then you're drowning in normal control flow with if null, if null, if null, if null, all the null pointer checks in the world, all these checks, all these checks. Then you optimize them with the normal optimizer things. And that works. And repeated null checks just disappear. Turns out that if you do a little tracking of nullness while you're parsing your bytecodes, you can even discover that when I have to inflate this field load bytecode, which says if null, else load from pointer.field, you already know that pointer's not null, so you don't even put the null check in. So you actually generated the code in the first place. So something like 3/4 of the null checks die in the parser when you're reading the bytecodes. Like they never even get emitted. And
Oh wow.
90% of null checks in particular, 90% go away out of the optimizer. and of the remaining 10%, half get done with are considered to only fail if something stupid happened, and so they're extremely low frequency, and so they're tested with another array memory op. And if that memory op NPEs, throws a SegV, you look at them in the table and say, "Oop, I did a null check failed here," and you do the null check thing.
That's a lot more optimized out than I expected.
Yeah, so the null checks clean out nicely. The casts clean out much the same way, um, not such a high number, but if you put a cast in the code, there's after inlining and then class hierarchy analysis and this and that, there's like 50% of the casts that you wrote in the code the compiler can toss out. The ones that remain have almost always have a one clock cycle implementation. That's a load compare branch on a predicted branch. So you fall through on the predicted case. And so it's one clock and doesn't burn any branch target buffer, branch target cache.
I don't want to name names because it's a personal project, but someone's personal project, his compiler was more than 10 megabytes and had a lot of exceptions. And my compiler is like less than a meg, and my
Okay.
IDE is less than a meg. So I was just like wondering, he had no dependencies in his project. So I
No,
was just
where
wondering,
did this come from versus the cost of
oh,
acceptance?
because I think because he does use exceptions in his compiler, his 10 plus megabyte compiler.
Oh,
I
yeah.
And you
I
think
don't have
that's
any
responsible for code generation bloat?
I think that's might be responsible for a third or a half because I don't understand why, like everyone I see, every C compiler I've seen, I mean, every compiler I've seen that was written in C was like in the kilobytes, and he wrote his in C++, used exceptions, and it was more than 10 megs. So I was wondering what went wrong.
In the terms of compiler implementation, I looked at several people who did things where they had special exception nodes or exception behaviors, like a basic block was a classical basic block, except there were exception points all through it. And so they had things about how they scheduled things that couldn't move within a block because it had to not cross an exception or it did or it didn't or whatever. And I looked at a couple of those back at the time and I was like, God, this just makes life more complicated. Just blow them out as normal control flow. And suddenly you get these really short basic blocks because it's thing and then safety check, thing, safety check, thing, safety check. But it's a normal basic block. And all your normal compile optimizations work and all your normal algorithms work and all normal, all this works. You don't have to tell anybody, you go hire a dude who's a compiler guy. You don't have to learn any exceptional shit. It's just a normal compiler.
So
The
it
one
should
funny,
all optimize out. Like the
yeah,
exceptions should not
and then
cause.
right.
Um,
Right, and
huh.
then it mostly optimizes out using classic normal compiler optimizations. Okay, so it makes the compiler a lot simpler and gives you a clean, clear focus on what to optimize for. You got some normal junk control flow that looks like repeated checks, and the earlier checks up here and the ones down here, it post dominates, I can get rid of it. Well, I wrote an optimization that said check for post dominated by blah, blah, blah checks. That cleans up user vote as well as safety checks just fine. So
You don't get complexity from the fact that things can bubble up and the signatures of kind of every function between you and main changes because it's now also can throw this exception.
okay, so now that's the normal. I just talked about normal code gen. There is a thing that when the exception happens, what do you do? What do you need to make it happen? So what we came up with, well, what I came up with was safe points. And a safe point had everything in it. It was a function call, normal everyday function call. I had all the compiler optimizations that go with function calls that took in as arguments all the things that were necessary to pick up execution in the interpreter. So if you had some amount of state and you inlined a whole lot, so I have an A called B called C, and I have an inline C into B and B into A, and somewhere down here I'm going to throw an exception. The inputs that function A needs and B needs and C needs at the point that you're throwing are kept as inputs to the safe point. And should you go down that DOPS path, those things had to be kept live, so you kept some things live. And then the DOP jumps into into the VM, into C program, and he introspects the stack and pulls out all the things that you put into the normal calling convention, which means you had way too many, so they spilled and they were on the stack. And then the VM said, I have this table that tells me at this call site, here's the mapping between, what got spilled to the stack and what the interpreter needs. And that's how you repack into the interpreter and can carry on using the interpreter for your actual throw.
And
So
you don't get code bloat for all of the exceptional cases because you're carrying around the interpreter to handle those cases.
yeah, so in the
I
IR
don't know
and
if
then
C++
in the
would have
generated
that same
code,
behavior.
you're carrying around for the interpreter. So you optimized for it. You did things like dead code elimination out of the interpreter. The interpreter has these bytecodes that are going to run, but if I just hand you a null here, he won't ever look at it. It's alive in theory, but he's not going to touch it, so I could get rid of that. So a bunch of that shit happened. But the real one was somewhere up in here, and I'm inline A to B to C, and I'm doing shit down here. I had to have a thing alive for this point way down here, but nothing in between. The compiler cleaned the rest of it out, except for the debug info. So the register allocator spilled it. He spilled it early and out of all loops. So a long time ago in a galaxy far, far away, the thing you needed for the interpreter got spilled to the stack, and spills to stack are super cheap on an maybe an x86 too. It's half a clock or something. And so the cost was minuscule in terms of runtime and the generated code to carry that information around. The bloat from the compiler IR side was I had a node which had 30 inputs, a function called 30 odd inputs, one for all the A's and for all the things that B and all the things that C needs at the point through. That just meant that I had a function called a bunch of IR inputs. Nodes and edges are cheap, so fine. When I generated that instruction, I generated a call op, but then I put a table off to the side, and the table was walk all the inputs and lay them out so that the VM can read them later. That says at offset 1, 2, 3, 4, 5, 6, 7, 8. I'm talking about frame A's this and frame B's that and frame C's this. So the amount of compiler code to manage that state was mostly not. It was the normal things you did in calls. So that was all normal from the call itself. There was a generation function that said, given the nested inlinings and the point at where I'm building the table, go walk my inlines and go walk the nested things or whatever and build a table that gets picked up on an exception. So it was just a little bit of code to go build those tables.
I'm
And
wondering if you
nothing at
need,
all in the compiler IR in terms of special code and logic to deal, other than managing the safe point had a lexical scoping couple bits that said I'm A or B and C, where this range was the A's and now the B's and then the C's. That was all straightforward.
isn't there one difference, like for instance, in C++ compared to Java, like you have destructors, right? So when you unwind the stack in the C++
Yeah.
case, you need to run all kinds of destructor code. Do you
That
think that?
what I just described would work fine on C++ as well.
Oh,
When you threw an exception, if you were going to deopt, you went into the interpreter, which if I had a C++ interpreter, would start running the destructors as the semantic for how the interpreter worked. If I'm catching the exception in the generated compiled code, so I've made an exception throw turn into a goto inside the compiler, which totally do, then I have to do all the unwind semantics, but I do them by treating them as normal bytecodes. So C++ is not normally done with bytecodes, but you could imagine I had a bytecodes for C++. The way that Java did try finally was I had this range. If you threw, you went over here, and then you did the finally code. In C++, I would do something very similar where if you're in this range and you're throwing, so this compactness the bytecodes is why you do it with ranges and bytecodes. But then I go to the unwinds, and the unwind finally pieces said, now unwind X and unwind Y and unwind Z in whatever order. Those are all just bytecodes. Okay, now I have a wad of bytecodes that implement the C++ spec for construct and deconstruct things on the stack, hand it to the compiler as a wad of bytecodes. And he chooses to bail out to an interpreter or he chooses to do the bytecode semantics. And the bytecode semantics tell them to do, hey, pull this thing off and call the destructor, and that's a function call, and you want to inline and blah, blah, blah. And the compiler's just doing the normal thing with bytecodes. There's nothing in the compiler that says I have to understand destructors. The knowledge of destructors would be put into the bytecodes by the C++ parser who's building bytecodes for C++. And compiler has no clue, doesn't care, won't, does the same thing. No impact on the optimizer at all, just the parsing.
I got a story about compile times if you guys want it.
All right.
Yeah. So just because it was spoken earlier, my mic wasn't working. Um, in so the C++ standard headers are insane. If you include print, it takes more than 1 second to compile.
Yeah.
Like this is in an empty project. You don't even have to call. I think you don't have to call print.
We're aware of this.
So uh, my include for my standard header, it includes like a hash map, arrays, dequeues, and a bunch of other things. Uh, that including one large file in my IDE, it takes less than 800 milliseconds to compile. So just one header versus an entire file is like a world of difference when you're looking at the STL and the standard library. I really don't like the C++ standard library.
I think that the C++ really needs a module system, and
Well, they have it. They added it, but it's not been well adopted yet, and it's still rough around the edges. C++ modules are half here.
I tried modules and it just did not compile for me. I tried it in GCC and I think Clang.
Well, yeah, you probably need to be using a newer version, and then even then, like I think Clang is relatively okay. GCC is kind of. Last time I checked, they still had a bunch of stuff that was missing and wouldn't work. But you could do some like basic module stuff with GCC if you have a new enough version.
I think I have the current 15.4 and yeah, I just didn't like the whatever code I put it in it.
Let's see.
I have to have GCC doing the optimization because for some reason Clang is
and that is
so
not true in the
pardon?
chat.
No, that was just a joke.
Okay.
Totally 100% joke.
I still don't really understand what C++ modules are. The concept of a compilation unit has been part of C and C++ for a very long time.
The
What
only
makes a
way
C++ module different than just I'm invoking GCC multiple times with several different compilation units, and then I'm going to link at the end?
right.
So
I mean,
The module in my head, the only purpose for it is to say, I have a pre-cooked list of all the types of this header. Don't include the header. Get me all the types for the header in a form the compiler understands directly without parsing. And I should just be able to read a file from disk that's the headers, slap them into memory, just like a file read and done.
Okay, so it's about making the difference between a CCP and a .h file. Go
I
away.
hope there would be a giant performance gain because you're not parsing the many hundreds of inline megabytes of headers. You're sucking from disk pre-cooked headers, basically, pre-compiled headers with all types, all known ahead of time. This is what Java does, right? This is what class files are about. You go get the class files, they have the pre-cooked headers essentially already there.
So here's a
you know what
useful.
would have been a great
Pre-cooked
idea?
Jim pre-cooked like a well described type format in memory, like what you would do after you proved that you had the correct types. Not really, not even as BSON, denser and
But
more
if these are
guarantee
essentially
state.
in .o files, they could live for decades. This isn't like something that just has to be a stable ABI
There's
for
a
the
class
length of the
file.
invocation of the compiler.
Yeah, what I'm doing is simple is put them in .o files instead of a class file, but they could live for decades. But the real goal is to open that file, read the WAD in, and deserialize it. But the deserialization wants to be as trivial as possible, and then it has all the type info that you had when you touched the file the first time with the optimizer. Anything that came out of the optimizer is useful type info. That's in the header.
I just worry that
yeah.
that's going to tie you to an ABI that's going to be painful
No,
over
no,
time.
no ABI. It's type info. This is separately from, there's code generated too. So I produce some code with an ABI, but I have type info. The type info has to have a particular layout so I can read it over time. Like it has to have a versioning and history and shit. But if I'm reading it correctly, then like the C++ class format, there's a verifier that you didn't hand me random bits you scribbled on disk. That's sensible. But now I have all the type info completely pre-cooked, ready for injection straight into the optimizer.
But
And
that's not what C++ modules do, right? I mean,
Well, that would be my head, what they ought to do.
Yeah,
That's
but
what they do.
I'm
Okay, fine.
no, I mean it's like a pet project of some senior architects
Yeah, I have no idea. I have to go
that
hunt. I
claim they
Brian
have
hunt in a second.
multi-million lines of code deployments of C++ modules, but nobody can see them because it's a secret and proprietary, and
Oh,
all the benefits are long gone because at no point did they ever want to restrain or restrict uh, existing C++ code. So yeah, I have no idea. It's
yeah, right.
I mean, if they couldn't make a C++ work after 10 years, maybe it's not going to happen, right?
I think the reason why the standard made modules is because they couldn't, like, no compiler vendor was actually going to make their code base or compiler multi-threaded. So every compilation unit had to reread the includes every time. So they thought, oh yeah, it would be a great idea if we just made the module system. So that doesn't happen. It didn't
Remove
work out.
pound
It did not
included.
work out at all.
No, the modules actually work pretty well. When you can get, so like there's a little web page you can see the compiler support, and even GCC I believe is still partial, but like have been demos where they show the compilation time using the modules, and when they work, it's very fast actually.
It improved.
Uh,
I
th- let's see. So
I thought that just
And find
if
tutorials on them and shit.
I thought if you just include your include if you improve your includes, it would just be better by itself. So I don't know how, like, if the module itself was the improvements, because
Modules
I
are
don't
an
use.
alternative. Okay, from the C++ website itself, they're an alternative to some use cases of headers, which is what I would expect it to be. That would be the goal. All right, never mind.
'Cause
I'll throw
not
this on the
using the
links.
standard and having a like well managed includes all my projects are like less than 2 seconds build. Even when I do undefined sanitizer, it's still less than 2 seconds.
This is
You
C++.
know, I wouldn't mind developing in that speeds, and I think it's entirely doable. It's just I'm coming at it from somebody who's extending LLVM with MLIR to go do an AI compiler, and that's not,
Yeah,
he does not have 2 second compile times.
yeah.
No,
Yeah.
not even remotely close. This is like 30 seconds to a minute to 2 minutes for some of the bigger files. And the big in terms of headers included, not necessarily the volume of code in the file itself isn't that big. It's
I feel like I asked this before, but what's the slowest compile, like the largest Java code base you compiled on? What's the slowest compile time you experienced? Because I
for,
think you said
okay,
it was less than 10 seconds. I think that's what I asked before.
break out Java C from the C2 JIT. So in a large project like Hedera right now, if I do a from scratch build, it takes several minutes. It's not all Java, it's a lot of other things in that build process.
Yeah.
So, I can't say how fast Java C is running. Now, you can go ask Java C that question kind of directly, and it's reasonably quick to produce class files. There's no optimizer running in there, it's just parsing. He's reasonably quick. I don't have issues with Java C being slow in anything I do either. And then, of course, the JIT's really quick.
Yeah, I was
So,
always amazed that Java C is still around. I figured
why?
we would get to the point where people were just invoking raw
No.
Java code.
Yeah, history. Fine. Back in the H2O days, I produced Java in the core in the running process and then compiled it. Actually, I was doing it for Cameron's Ecstasy too. And it's pretty quick. And it's very easy to read the Java code you're producing. So it's a useful way to,
But like for AA, you didn't reach for an AAC step. You just
yeah,
read the AA files and
yeah,
start interpreting and JIT when you
yeah,
need to, right?
yeah, yeah. It's fast enough. And I think it's true
Oh,
today.
why?
Right. I don't know.
What was your rationale for wanting Java C and not wanting something like that for AA or simple?
Well, it wasn't necessary. For simple, I'm headed for people who want to live in a C world, coming from a C world, and they're going to link in foreign functions, and so I was going to daisy chain off the .o format. Um, for A, I was just like, if I come to I need an internal two-step process, I'll deal with it then. I don't see it necessary. It should be fast to parse. It is fast to parse. Okay, fine. Then why do I need to have another? I'm with you. This is like JavaScript. JavaScript says straight from source. Okay, I know work for JavaScript will work for me.
Yeah. I often want a tool chain that will sort of do both, that I can just say, AA space the name of my main file, and it will go propagate through and find all the things
Yeah,
that got imported.
right.
And
That's
at the
the
same
goal.
time, it's nice to be able to say AA dash dash build, here's my main file, and get it to actually produce an exe that's
That's
got
what Simple's doing.
the entire VM and everything in it. So you just like run.
Right. That's what Simple's doing. If you ask for an exe, you get an exe, and if you don't, you just execute your code. And
So
there's
the
a
only formats that
.o
exist for
version.
simple are going to be the raw .simple files with the code in them,
Yeah,
the .o files for a module,
yeah,
or the .exe for an executable.
yeah. And I have those flags floating around on the command line to go run.
That was one of the things that I think Go really convinced me of, was you don't want to have this distinction of here's my Python VM and then my Python binary, and here's my Java VM and my jar. Like, just compile the entire VM and the code into one
Ah,
executable
and
that you can just drop on a server and then run.
that's interesting.
Well, no, you can't do that because with Java, you could take that code and then you run it on a server, and it doesn't matter if the server is running on ARM or x86 or Spark V or Spark or RISC V or whatever. Like,
You needed VM, you needed Java on the server of the correct flavor.
right, but what I'm
Like
saying is
what
like with
Aaron,
Go, right?
there's
You
a different
compile it,
thing.
but it'll only run on ARM, or the binary will only run on x86 or whatever. Like, yeah, you
Oh,
don't
fat
have the
jar.
runtime.
You can make a fat binary. You have a limited count of them, but
Not
there
all
aren't
not
a
all
limited count
operating
of
systems
popular
support
CPUs.
not all operating systems support that though. But yeah,
I don't
was just
know how I could make the operating system defeat a fat binary. If I give you a binary that first thing it has is a wad of instructions that'll work on every architecture and will break out to different paths according to your x86
I
ARM or whatever,
I
then do the
don't know if that
OS
exists
checks. I
for
can
all
write that code.
architectures.
People have written
Yeah,
that.
so that style of fat binary used to be popular. Most of the fat binaries that I've seen recently just have an elf header that's got the little jump
Yeah,
table in it that says, this is the magic number that means ARM, this is the magic number that means x86, this is the magic number that
right,
means, and here's the offset into the binary to the first instruction to each of those. And the operating system looks at that little table in the header of the elf and does the jump for
right.
you.
And Ryan was
I've seen
saying,
that much more often than I'm going to make some instructions that are both valid x86 and valid ARM and jump to two different places depending on which way you
right,
interpret it.
I have
Like,
done
that
that.
used to be a thing, but I haven't seen it in a long time.
Okay. And I agree, this what you just said was the right way to go. But Ryan was saying, no, but I have my non-OSs do this. And I'm like, you can't make an OS that would refuse me because it would just see the normal entry point. You're going to run some code? Okay, run this code. What does it do? It first figures out that you're on an
Yes.
x86 or a Linux, blah, blah,
If you
blah,
won't
or
play
fine.
nice with my jump table, then I can play games with
Right. And then you're
multiple
off, you
interpretable.
go through your jump and you're off to the correct place. So I don't know that the OS could defeat such a fat binary. You can run code at all.
Maybe for like ARM and x86, but like if you have 16 different architectures, I challenge you to find like
Oh, this is a
Do
solved
you
problem.
have 16 different
Yeah,
architectures?
yeah, differently from there. Yes, exactly. But this is a solved problem, Ryan. People asked that very question 20, 30 years ago, and the answer was we could do it for any set of things as long as there's something that can be differentiated between them. We can do it. This is a solved problem. And
I
I
don't
have
know
to go
about
hunt
that.
up the literature.
Also, what about the ones that like if you have a file format that's like what is your architecture and you can only put one field in there?
It's if you suck down an ELF file or something, some sort of architectural neutral distribution format that I'm willing to produce. You have to have a format that the OS is going to open the file up and read some bits out of it and then jump to somewhere and begin executing, right? So assuming you're taking ELF, not a Mac only thing, like I might have to make a separate binary for a Mac because the Mac OS wants a separate binary. What's the name of it? There's another binary for Mac.
Mach-O.
Mach.
Yeah, so like Windows uses exe files, or sorry, COM is what they call them.
Yeah, but I think
Mac uses
those,
Mach-O,
one or
and
more of
then
those can be tricked around, so it's just a file rename and will work. I've seen this done before too. The exe format versus COM format versus, I want to say ELF. And with a little careful arrangement of the table layout in the beginning, you can just have a file rename and it'll be valid in all different versions according to the renamed file. And
Yeah,
then,
that
com
sounds
is just
interesting.
like first instruction is the first byte in the file.
Mm.
Gets mapped in and started executing. There's no preloading of comms.
right.
Right.
But
Yeah,
the first
label.
few executions, bytes, which could be ELF headers or COM instructions, as long as there are no ops on an x86, you're fine. You just plow through till you get to something, you have some options on spelling it out. And if you hit that code, if you hit the next few bytes in, oh, you must be a COM file executing from the start. And then you
I'm
can jump to
surprised
the COM piece.
no one mentioned Cosmopolitan and
Yeah.
Ape.
Oh, well, here you go. Let's go take a look at this. I think PHP is on the way out, Aaron. That was what I had heard, but I don't know. What is Cosmopolitan?
Yes, Facebook is replacing all their PHP with Hack.
Okay.
Isn't that old already? Thought that was already dead. Heck.
Oh,
But does
Cosmopolitan. Okay.
Wait, did they replace Hack with something newer and I missed the memo?
Oh, what language is that? Because I heard of like HAXE, but I don't know if that's where you're talking about.
So I'm going to put the link to Cosmopolitan in. But yeah, he apparently makes a format that'll run on Mac, Windows, Linux, FreeBSD, OpenBSD, Net, this, that, the other thing that has been POSIX approved polyglot format. Okay, that's
Okay, I feel like that's a hack or a workaround. It's not like actually solving the problem that Java has, which is compile once, run anywhere. Yours is like compile once and run in specific operating systems that I
yeah,
have developed a hack for.
that's correct. Same for the VM. It's you have to have a VM for each of these different OSs and chips. And there's a finite count of them. The giant thing, the giant problem that Java offers to solve is we'll do it everywhere. That works as long as Sun, then Oracle actually keeps producing VMs for whatever new things come along. And they've been pretty good about it. And then new things quit coming along, and so they've kind of stabilized, and we're all good. Um,
I mean, it also the advantage though is you compile it once, right? And you can take a Java let's say a new operating system comes into existence, and I have a binary that was produced by a vendor, and the vendor has gone out of business.
right.
I could still take that binary and then run it on the new operating system that came into existence after they went bankrupt and liquidated, right? Because
Yeah.
the
You're
but you can't.
saying Oracle goes out of business, then a new OS comes along. No one's building the JVM on the new OS
No,
because
no, no, no. What I'm saying is like, let's say I have a Foo Widgets company, right? Widgets company builds a widget Foo Blazilator
right.
application, and so I have this widget Foo Blazilator jar file, right? And let's
No, you don't
say,
have a jar, or you did it with Java. Okay, if you
like,
have a jar, yeah,
yeah,
okay.
I did it with Java. So I compile it with Java, I get a jar file,
Right,
right?
right.
And then the Foo Basil Widgets company goes out of business, and now there's a new alternative to Linux. It's Rust Linux, Linux, and
Yeah,
it's
whatever.
binary
Right. You make a
incompatible.
thing. Yeah, yeah, right,
Super secure, binary incompatible with existing Linux executables. Only
right.
runs Rust programs, or then someone rewrites the Java virtual machine in Rust or something. I don't know.
Yeah, right.
So
You get a
anyway,
new
there's a new
JVM,
operating
and he
system. It
reads the
doesn't.
old jar file, and that's fine.
Yeah,
Yeah,
and then it runs, right? Whereas if you're like Go and you compile everything ahead of time, and then your company that has the source code goes out of business and you just have that binary, now you can't run it on the new operating system without an emulator.
yes. And that's what the JVM is. It's a giant badass emulator.
Right, but it is an emulator, but it's like a reliable.
It's a reliable, well thought out, well designed emulator. Yeah, 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 yeah. Yeah, that's fair enough.
Yeah.
Simon,
So
you raised your hand? No? Okay. Fine. Yeah, fine on all these fronts. one of my goals out of AA and Simple between them is to see if I can come up with a runtime that could be portably used for other people to do other languages with. Um, so underneath the hood and the far end of things, I'm looking at, what it takes to have a portable optimizer and portable execution to a portable machine and make it relatively straightforward to port to a new platform with.
Was that ever the goal of Java's JVM?
Whose?
So I was thinking, I've heard stories. The Perl 6 VM, they were very focused on this is going to be a great platform for people writing their own languages on.
Oh, Perl 6.
But it ended up just being used by them.
Right.
Whereas to my understanding, the JVM people were not thinking, we're going to create a platform that you can run arbitrary languages
That's right.
on.
It was
And
very
we ended up
surprising
with a
when that
lot of
happened.
JVM languages.
Yeah. It
And
was
I think
actually,
that they just got the good of that because, it was born as a small talk VM and it was rewritten as a Java VM. And it just has an evolutionary history of having multiple languages, left it in a place that was reasonable to have multiple languages.
no, the small talky aspect was only brought over for the on the fly code gen chunks of things, really. I mean, the VM, it's more or less written by hand. I guess the exact VM was the first version. The second one was some small talk concepts and some amount of the code, but not a lot, came over to be the hotspot version of things. But most of it was the concepts you wanted. But the
Yeah,
goal
so
was
mostly it
just to
was the
run
fact
Java.
that get class for name remains in Java to this day because hot loading of code was a small talk concept.
Yeah, and that was yes, and then get class for name had to be there. Yeah, absolutely. That was one of the concepts I think came over. Yeah, I'll agree to that one. But it wasn't
And now you
trying to
can get
run.
class for name at runtime and hand new code to
Yeah,
the system, and that made it possible to do pretty arbitrary things.
right. No, I think the thing that happened first. So the question was, why did Perl 6 not take off as a VM for handling everybody? And I'm claiming Java came along, wasn't thinking of allowing other languages. That was never in its concept at the time, but it was just a solid, really good general purpose execution engine that happened to be targeted up front for Java, but you could do almost everything else. You couldn't do super low level device drivery things, but everything else you could do. So all the normal execution shit, and then you covered all your bases with the class for name and all the low level optimizations all worked in terms of add, subtract, multiply, divide, and pointer math and inlining and all this kind of shit. And it had safety and it had GC and good code gen. And now you get a billion people. Okay, at some point you got a billion people using it. Okay, a million people using it. You're going to get people to try alternative languages on it because it's already a solid platform, and there's a huge count of people doing it. So if I write simple as an optional backend for another future language, I don't expect anyone to pick it up any more than Perl 6 would, unless for whatever reason it takes off as a real great language. And I'm not expecting that. It's me trying to show how you can go write these things. So some knowledge I have about how these things work doesn't get lost when I walk out the door, when I leave this place. So that's the reason. It's teaching of some kind. Leave an artifact behind that lets other people figure out what's going on.
I mean, it does seem like the simple artifact is better at teaching C of nodes than go read the JVM code.
Yeah, yeah, yeah. No, 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 no. Fine. Well, I understand how that came about too.
So
Now,
one thing I found very interesting about Perl 6 was I guess they learned the lesson from Python of that whole rename from Python 2 to 3. Everyone could not find what they were looking for because they got the wrong language. So Perl just called Perl 6 something else. It wasn't Perl. It was like I think it started with the R. Does anyone remember what it's called?
I'd go ask the interwebs, but I don't know.
Okay, so and then that's the thing because people know what Perl 6 exists, but they don't know what it's called. So I don't know if that was a great idea or a good idea or a bad idea, but it's just funny.
Raku.
Yes.
Yeah, and that was me going to the interwebs and say Perl 6 name, and the answer comes up Raku.
Yeah, so at least it's like the first result if you try.
I actually have been thinking about someday making a virtual machine because like I've noticed like JVM is great as long as you want to make a garbage collected language. But
Yeah.
like, what if you want something that's like a sort of a portable binary for like a non-garbage collected language?
Right.
I would like to see something where I can just have this sort of portable binary for a non-garbage collected language
Have
and
you
then run
tried
it.
the WebAssembly VM?
He's garbage collected. Yeah. I mean, JavaScript itself is garbage collected, but I believe WebAssembly had the garbage collection go in.
I think WebAssembly does operate on bytes. I'm not sure.
It operates on garbage collected system for sure. Web, ASM, GC. What do I get? A compiler author's guide to WebAssembly GC. That seems pretty straightforward. So yeah, I think it's GC. So not WebAssembly, but there is right. So Rust, right? You know, something. But what do you want out of your VM? You don't have GC, so what other things would you get over a bare binary? So writing
So
module,
that's one thing I really don't like. Okay, so people say they like WebAssembly, this and that, but I never found it useful. Like, there's no API.
yeah.
There's You have to use M scripting if you want some PostX things and some C things, but no one wants to write their API, their like standard library or whatever from scratch. Like, you get nothing when you use WebAssembly. You get no portability because it's just it can run, but you can't do anything useful. There's like no API. So it's just like, what's the point of WebAssembly? Because you got no VC. I mean, you have no library and there's no GC. So you're just compiling C and
To
you
do
got to write your
compute
own standard
intensive
library.
things in the browser.
Yeah, yeah,
You
right.
can't. You have to write the JavaScript for it and then create a bunch of bindings for it. Like, it's not portable. Like, you can't do anything with it.
Why can you not?
Yes, it is typically used as a JavaScript accelerator, not as the sole language in which you are writing a program.
Right.
I
Yeah,
think
yeah.
I think what they're saying is that there is a WAVM thing that lets you run stuff in do a WebAssembly VM.
Like
I,
Node.js. With
it,
it's JS without the browser.
so like there are stages like it's portable. It works on Windows, Mac, and Linux, and support for AR64 is work in progress.
Yeah,
Like
but that's not
it's not like what I'm thinking here, right, is like not just cross operating system, but like I want something where I have a bytecode format and it can run on different architectures and do JIT compilation to sort of semi-native code. And then I could read and write files or like have a command line utility and I just write it once and compile it once and then there's a virtual machine that runs that binary, right?
that's where
And
simple is heading. Yeah.
You know what's
Just leaving the
interesting is that
GC out, but everything else.
you can actually use use RISC-V like as a relatively good VM because it can be binary translated to quite a few targets very efficiently, and you can binary translate it much faster, and you can did compile WASM, for instance,
The
because WASM is not
the
very
thing I want to
fast.
carry forward to hand to the next generation VM, whatever the next VM I'm running on, has more type information that I get out of a RISC-V binary. So the class file from Java gives me all the types of everything, and I have to do some code gen to go make it execute. Okay, I do. And it has some bytecode format. Okay, it is, but it has types. And if I had a RISC-V instead of bytecodes, okay, that's fine. But I want the type info.
I think
Why do you need to add? Oh,
Well, that type info is how you're going to get your optimizations on the target you run on.
but the thing is, like, ideally, I mean, let's say the source language that you use is something that has lots of types, like C++ or Rust, and then you compile it to RISC-V in a very optimized, like
Right.
you go through optimizations then, and then
Mm,
you have an
Okay.
optimized RISC-V
Okay, so
binary, right?
there's a missed piece here. So I took one module and I compiled it to well executing RISC-V, And optionally, I kept type info or I didn't, whatever. And then I go to the second module and he compiles and reads the type info from the first. And then I have this chance to inline or not across compilation boundaries. And if I don't inline across compilation boundaries, the super optimized over here, getting called from over here at a fine grained optimization layer, lost a lot of performance because I didn't inline across the boundary. As soon as I inline across the boundary, I have to do cogen, and then I don't need the super optimized binary, but I need the type info. So now what pieces do I want to bring along? Well, I'm thinking I'm going to bring along some executable so you don't have to have a JIT. You can just run it without, and it'll just cross-link and just call, and it does. Or you're going to have a JIT, and the JIT's going to say, I only want the type info, blow the binary away that was there, inline, re-optimize, recompile, and run with optimizations. And then different people want different things. If I'm doing a tiny embedded SIT chip, I'll just take the precompiled binaries and not inline and not optimize. And if I'm running on my desktop or a phone, the JIT cost is minuscule compared to the cost of everything else. I'll JIT and run the JITted code, and that'll be better than not running the JITted code, or than running the non-optimized or the uninlined across the board. So you have to decide where
Yeah, I saw something that was talking about the ways in which Java tends to run inside credit cards.
Yeah. Why?
There's no JIT there. They just
No.
interpret.
Yeah, right. Yeah. This
And you're like, well,
that little
yeah.
guy right there. Yeah. Why? All right, fine. I mean, some crypto thing or another, I don't know.
I mean, it turns out the chip stuff is a little bit older and a little bit easier because it connects to the power in the device.
Yeah.
There's a VDD and ground on the little chip
Yeah.
points.
And I think he
The
takes there's a radio and those are radio, the big
the wave ahead NFC thing
yeah.
starts with an intense pulse
Yeah.
that is then captured in an inductor on the card,
Right, and that's
which
your power.
charges a capacitor,
Yeah.
and then the capacitor drives the chip while it does the math until the capacitor dies.
Yeah.
So those have to be much more power efficient because they got all of the power they're using to do the exchange from the initial pulse.
From the initial pulse, yeah.
Which
Right. Well,
is a lot harder than having a VDD and ground that are just pins on the card.
As long as he's doing some very straightforward bits of math, whether it was done with a
I do
Java
wonder how many Java instructions you can actually execute on an RFID pulse card.
I'm going to assume that they don't interpret Java inside the
There's
touch.
definitely was an effort made to do exactly that. The Java chip, Giselle,
I bet they do
power.
it in the plug-in chip, but like the RFID one, I imagine they wouldn't have much power.
I don't know. If I'm not doing a whole lot, the overhead of an interpreter in hardware as your instruction set, it's just a stack operated instruction set, has a particular encoding. I'm only going to do however many hundreds of bytes of byte codes, 1,000 bytes.
I mean, you definitely don't have a standard library, but
Don't have a standard library. It's all in ROM. There's no loading it. Yeah. Now, why was
but
it?
essentially your task is read the message, sign the message, send it back.
Yeah, right. And now, why were you doing that in an interpreted chip with Java somehow involved? I don't know, but that was definitely the effort.
I wonder if they try to
So the
change-
why is actually clear. It's because they were designing the software signing protocol in parallel with designing the chip. So they didn't actually know anything about what the chip would look like, other than that they were going to write a JVM for it.
I gotcha. That makes
So they
sense.
did all the software against
Got
the JVM byte codes,
All right.
and
Learn a
then
little
they
more
just
history.
tried to get that to run.
the code is like ROM, right? It's like they don't plan to change the bytecode.
Not
or-
now, they don't. When it was you were saying, when the time they were designing it, they did. And they probably had you could burn new ROM on for a long time before the people said it's done. And we'll
Yeah, the
make
ROM
it.
has both the program and the key just
And the
burned
key.
into it when the credit card is made.
Yeah.
And the process for updating it is they send you a new card in the mail.
Yeah.
Do you think people would be interested in like building a new VM and like for like non-GC languages?
Like I said, that's what I'm doing with simple. It's not
Is it
there, but
is
that's
it like, are you gonna document the bytecode? Like,
yeah, that's the what is going into the .o files as a type header that I can suck out that would include enough to execute executable format. So that'll be documented, and it'll be essentially serialized CF nodes, like things like cut down and chop everything as tight as possible to go into serialized
You said
form.
simple has no GC?
No,
Is there a
it's not.
free
No,
command?
it
Like, how do
couldn't.
you not use infinite memory in a simple program?
I'm sorry. Well, oh,
How do
right.
you
But
give
no, no.
memory back in a simple
Yeah,
program? Is there a
the
free
goal
instruction?
the goal there is to extend the type system to do some sort of Rust-like type analysis. What is it, Hiru or Hiku? That Matt came around with one that I've looked at before. It looked really sensible. It would be some sort of compiler-supported deterministic memory reclamation, not rough counting, not GC.
Can you give
but
a
the
sketch of what that looks like?
I have not. So I only know that such things float around, and I think I could do it. Hilo, there it is. Adrian says Hilo. That's the name of the thing. Looks like a sensible way to do memory lifetime management. Maybe it's not the right thing. I don't know. I know I have
but
a type system that's I can do a lot of things with. So my theory is I can manage to do lifetime tracking. Like all things with fixed lifetimes like Rust or whatever, you have to do something to give up. Not all programs, not all valid programs will be past the types. But if you pass the type system, he'll do the memory reclamation for you. So it won't be GC, it'll be deterministic.
wait, so is that going in like your front end, or is that gonna run in the JIT? Because like that would like very much change what languages can use your VM.
No, it runs. Yeah, it runs on all places. So the convenient front end has something that lets you make objects and get reclaimed without having a whole lot of annotations floating around. The back end demands an IR that has the correct type info. So no, not all IRs are legit. If you just hand me a wad of bytes, it's almost surely not a valid program. So you have to hand me a valid program that includes that I can run the type analysis on it that says I can detect that the lifetimes are detectable, manageable, and then the JIT or the generated code or whatever does
Okay,
the
so you're handing off some of that to the JIT. So you're not creating like a general purpose low level VM.
it would be a general purpose low level backend, except it won't take every possible program. It'll only take programs where I can prove that I understand the lifetime.
Okay, so what I'm saying by general purpose is like what I'm thinking of when was talking about like a low level VM for like similar job is like I should be able to take a C program and compile it to a bytecode that this
Right.
VM can run on
Right.
like Spark or
Right.
x86
I understand. And I
or
will not do
whatever.
that because I can't prove lifetime. So in the general purpose C program, you can double free or you can use after free.
Yeah. So
And I
that's
would say the Java bytecodes by themselves say you can't run off the end of an array, you can't do a null pointer, you can't do this, you can't do that. They remove some valid programs from the universe to get things that will run without failing or crashing in the classical C sev way.
All right,
Okay.
so I guess what I was trying to say is like I want to know if people are interested in like building a universal but like a low level VM
Right.
for like running C like languages,
What
not
are your
necessarily C.
semantics? What are your semantics for use after free?
Maybe
I
there's like an alloc instruction and a free instruction, but like anything above beyond that, like if you want to do constructors,
no,
destructors, that
no.
would have to be in your
Start with the
IR
low level.
generation.
Right. Yeah, back up. No, you didn't answer the question yet. I want to hear how you solve this. I malloc an array. I use it briefly to do something stupid. I don't know, Mandelbrot's, what the fuck. I free the array. I then read from the freed array.
It would just
What
crash.
happens?
Segfault, crash, corruption, who
Right.
knows?
No,
What my
no.
my goal is not safety. My
Okay.
goal is like I want to have something that runs across multiple architectures, assuming it's given a correct input.
Right. And I have a different goal. I have one that wants to run across multiple architectures, giving a correct input, but I have no undefined behavior in it. So use after free is not possible. I won't start your program if your program might use after free. I'll tell you instead that you don't have a valid program. Same as Java C will tell you you have invalid bytecodes. You can write any kind of bytecodes you want by hand. People used to do it all the time. They'll fail the verifier. So he'll come up and say, this isn't a, look, it says called dot class. It looks like a class format. Your bytecodes are not valid bytecode. You're not a valid program. Get out. So that's where I'm headed for that one.
Quick
And
question.
go ahead. Yeah, use after free, I will disallow by design of the language or design of the backend. Sorry,
Just
go ahead, Adrian.
no, I was thinking it doesn't. I mean, it sounds a bit like LLVM, right? Like, or for instance,
Well,
which
LLVM
is
allows use after free, and then you get crashes or undefined behavior, and shit happens.
LLVM though, despite the name originally
But
standing for
wait,
low-level virtual machine, it's not really
yeah. I
a
want to hear. I
virtual
want to hear because
machine.
I don't think I understood all of Adrian's point or question. Did you have more to say there?
no. It was just that Ryan described something that like you can take a C-like program,
Okay.
reduce it to some kind of IR that then you can like run on different kind of.
Yeah,
And
yeah. So the closest thing in LLVM was SPIR-V, which was like based on a frozen LLVM spec. But LLVM is not like inherently suitable for this for a couple reasons. One of them being that the bytecode format keeps changing between LLVM versions. So like LLVM's bytecode for like 16 point something is different from for the bytecode for like 17 point. Like
I would
it's
claim
not.
that that's a different problem. I'm trying to solve the one that says you have no undefined behavior. It's just not allowed by the language design. You
Uh,
can't run off
uh,
the end of an array. You can't double free. You can't use after free. So on.
so Cliff, I've been wondering why do you want like another language that you can like look at as a reference? Because I thought that designing something would be like pretty intuitive to you because like you've done so much with C.
C allows use after free. So I want to change to a language that disallows use after free.
Yeah, but you write C programs for like a long time. You have no
Right.
problems figuring out what the memory problem is, how to write code without having a memory problem. So I figure that you can just design something around like how you write
How I
like
did it
C
back in
code.
the day when I did hotspot.
Well, no. I mean, like, okay. So the way I design my language is the style that I write my code in, like my C code. I just make sure that whatever I don't intend to do, I just like put something in the language that prevents me from doing it. Like you just said, use after free like multiple
Right.
times. My
Right.
solution was to not allow alloc. Like you would just
Yeah.
have a way
Oh,
to say I want an object, but you can't
alloc
like.
is to some kind of, I want an object that's dynamically computed because I don't know ahead of time if I want one or a million. I don't know a lot of things about when I'll make them or where. So I want to say at some point I can create an object and at some point it's gone. I'm done with it. And when I'm done with it, I can't use it again. So linear logics solve part of that problem. And that's, Rust makes heavy use of that. That's great. Other things where you want to have maybe other patterns than stack-based lifetime management, or you want to have certainly less annotations. Like Rust, in my head, to drown in annotations to manage that, and I think that's unnecessary. A lot of that I think I can infer with the right type info and the right type algorithm. I can infer the lifetimes.
Yeah,
You want
I
something
kind of
where the
get all of
compiler does the allocation and free inserts and leaks in similar ways to the ways garbage collected languages leak memory.
I'm hoping to not leak the way garbage collected languages leak.
Like garbage collected languages shouldn't leak memory. That's the whole
No,
point.
no, they
They
absolutely.
leak by you holding on to a reference that you
I make
thought
a
you had
linked list.
nullified.
I keep the head of the
Uh,
linked list, and every thousand times, million times a second, I add a new entry in the linked list. I never see the tail of the list. I never look at it ever again. So it's only leaked conceptually because my program isn't going to visit the millionth element down the list. But I just keep adding things on the list. Says
yeah.
every logging implementation ever. And suddenly you run out of memory because you logged and you never cleaned your logs out and you run out of memory.
Well, I mean, that's not a leak. That's just that's like
That is
keeping more things around than you
that
need.
is
It's just
called a leak
distinct.
in the literature.
Uh, uh,
It,
because
it, the,
Yeah,
the
for
it's
me, okay, for me, a
common
leak is when
jargon
it
term is that's
escapes.
a leak.
it's it's a difference between aliveness and reachability.
Yeah.
Reachability portability is a conservative approximation of liveness. So I think Cliff is on the money here.
When Cliff said leak the way GCs leak, I knew exactly what he was talking about.
Okay. So here's a fun one, by the way. It has nothing to do with anything except as an implementation strategy to get around leaking and garbage collected languages. I got this one from, I want to say, Bill Pugh, probably. Anyhow, uh, as you allocate more and more and more, and the garbage collector starts to run out of memory, he has lots and lots of things that you've leaked, and they're almost always a huge count of the same thing as a spine of a long chain of a linked list with a bunch of crap below each of the entries. And the garbage collector makes a following assertion. If you allocate again, I'll die and throw out of memory in the program's dead. So I'll keep the program running by claiming that since you've never looked at these in a long time, I just do that by using TLB mapping to track that you've never looked at these objects since forever. I'm just going to claim that if you were to look at them, oh, I would have found out of memory a long time ago. So instead, you're not ever allowed to look at them. So I'm going to say, since you're not going to look at them, I'm going to cut it off. Throw all that, reclaim that storage. And at the point of cutoff, if you do look at it, I'll then throw it out of memory. But as long as you never follow that linked list to the end, you won't run out of memory, even though you're leaking furiously, because I just keep throwing this shit away. But if you
Oh,
actually look at it back, I'd have said I would have had to have held on to all of this memory, and I couldn't. So I would have thrown it out of memory. Actually, I'll just delay the out of memory.
That's an
And that's
interesting approach. I'm not sure that's a bad. If you're okay with programs randomly terminating, sure. I prefer them to throw out of memory exceptions.
Malloc programs can
It was going to randomly terminate anyway.
Yeah, yeah.
Well, here's my thing. I prefer throwing out of memory exceptions and being able to recover.
But when you throw them, it's the same story, and you can recover from this one too. It's another out of memory, but any random C program malloc can fail. And I keep allocating with malloc. Well, guess what?
Fail, but you can recover. You can be like, okay, this is equal to null pointer. I'll do something else, like return error.
Right. No one ever does, but you do. Actually, at H2O I did, but I only did it for large allocations.
I would say C++ is better about this because in C++ by default it throws an exception, and you can't out of memory your out of memory exception because there's a special bad alloc exception location that's statically linked in.
So just so you know, the Java out of memory exception is entirely reliable and perfect in the sense that it follows the spec exactly. Carefully hand done by any number of people, me included. You get an out of memory exception.
That static instance, there is a static instance of the out of memory exception loaded when the JVM starts up.
No, there's some memory set aside to build the exception object should you throw it. But so you might as well consider it a static version. And then
it doesn't have the stack trace though.
No. Oh no. You get a perfect exception.
Oh, do you? Oh,
absolutely.
Okay. I thought if you really ran out of memory, there's this last chance ditch one that has. It's like it doesn't have.
Okay, so there is.
That's if you run out of memory while processing the run out of memory exception.
There is this cute little exception that makes this problem not nearly as exciting or whatever as you might think. And that is if you were to catch the exception and do any allocation at all, that will throw again.
That's what it is. Yeah.
Unwind out of your handler again. And so you'll eventually get one that the exception catch works and you can print or do something with it, tell. By the time that happens, you may have had recursively a dozen other throws that all got picked up and thrown away until you came up to the one. So it's perfect, but boy, it's like, Now tests for this prove that it's perfect. The tests say shit like catch the out of memory, increment a global counter that only gets incremented here, so I know that I passed through this handler, allocate maybe by calling print, which fucking allocates, throws again, gets caught again, but I've unwound a frame. And I keep unwinding frames and I'm marking bits as I go until I can catch without either allocating or I've freed up enough storage by popping frames. And when you pop frames, everything that frame was keeping alive can now be reclaimed. And then you can execute, do something. And that shit all works. Okay. People who actually make meaningful use of it, I did one time in my life. I mean, it can be done. It's just really, really rare.
Speaking of exceptions in Java, maybe this was my imagination, or maybe it's still like this and I just haven't noticed. But I think I remember, like in 2010 and before, a lot of Java programs would constantly throw exceptions and crash, like all the time. What changed to make it like, it's not like that anymore, right?
It
What
is
changed?
nothing changed
Yeah,
except
it still is
how people use the
totally
language.
like that.
Sorry, Ben?
Yeah, it's still totally like that. There's still bad code in the world. It
Yeah,
still throws, it still crashes. You can't trace the logic, and these
yeah,
projects go into the corner and die.
yeah, yeah.
Okay.
People can write bad code any language. And they can
Yeah.
certainly, class for name is both your friend and your enemy. You can certainly like call injectors. I read your class. I mutated it to a new class that wasn't the one that you intended by putting these injections in it. Then I ran it, then it crashed, and you're like looking at your old code, but not the injected version, who is like some auto-generated thing. It's impossible to read. Shit happens. Okay. People write bad code, they do. People don't
I
handle a lot of
remember
memory. People
I
don't handle a
remember
disk
with
full.
constants, like constantly crashes, but I was wondering if linters affected it, but I just couldn't tell
No, no,
because
no. It was crashed because you wrote some stupid thing. And the language is perfect about the tests, the safety check. So you blew some safety check in your random crappy code. Then you caught the exception and hoped you could recover, but you didn't actually recover. So that you ran again and crashed again, and you caught it again, thought you'd recover again, and you didn't the first time, didn't the second time, you crashed again. Not, no, no, no. And, yeah, I watched a lot of those happen. That was
I probably just
actually,
downloaded like a lot more random tools on the internet in 2010. So maybe I
no,
just noticed poor quality code more often back then.
I think it was people figuring out what it meant. There
Mm.
was a lot of, the first time people started using the JVM sort of in anger and earnest, where they took large C programs and rewrote them in Java, the C programs had bugs that came right over. Java caught them. They crashed left and right. This worked fine, except it was crappy when
Also,
it.
the memory model did get better defined over time.
Yeah, but that happened more than 10 years ago. That was like 15 years ago. That was you're talking about JDK
Yeah,
5.
I think of like 2005 is when I stopped seeing Java crash for motherboards
Oh,
disagreeing on what
another
the memory
thing
model
that
meant.
happened was somewhere around that time frame, we quit allowing JNI code to get called directly. We put JNI wrappers because people who were using
Oh, I bet
native,
that's it. I bet it's JNI stuff. That's why I used to see Java crashes and those
that
went
might have
away,
been.
is that
Yeah, okay.
we
We
got
got a
much
lot
better
more.
at not asking C++ programs to promise they'd follow the Java pointer model.
Yeah, exactly. That was it. We quit asking them to promise to be good because they were reliably not good. And because they were reliably not good, they reliably failed.
I do not look forward to FFI in my language.
Right, exactly. What's your FFI rule? So for garbage collected language, the Java experience says for garbage collected language, the FFI only hands out handles, not moving pointers. And you pay an indirection layer. The native code you call pays an indirection layer because they just refuse to play good with moving pointers.
And that handles just an int that's in a map somewhere, or
No, it's actually generally most of them dynamically are pointers to pointers. Literally, I'm making a function call. I put on my stack, I take a stack address and put the GC pointer. I hand you the stack address. Then I call in. Well, you got an address on my stack that's above you. Is the caller's address space. Okay, you did. But it's an opaque handle, and you're not and we tell it to you it's opaque, and we give it to you as a JNI handle with basically a void star. And there's some function calls you do to go manipulate things through it. Give me field X out of this handle. Give me field Y. Lock the handle. Lock blah blah. Blah do whatever thing. They're all done with indirections, and the indirections honor the GC, the moving GC rules. They do a normal GC load, which does a read barrier check and updates the pointer and blah 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 whatever things. So the native code can't cheat. The other one the native code would do would be hang on to a handle. Um, hang on to a pointer and not let go of it and not to
yeah, I
tell anybody
claim
to
I have
hang on
zero
to it.
copies.
Oh, you broke up soundwise. Say again.
I said claim that I have zero copies when I actually have one.
Yeah, exactly. Yeah, right. And then we freed the memory and then you were looking at somebody else's random memory after a while. Right. So handles all the way. If we think you're going to have a long lifetime on your handles, we do allocate them in an array in the VM of just pointers. It's a garbage collected array. We hand you the array address, but that array itself is malloc and doesn't move. It's not GC'd, but it contains GC pointers, and the GC is aware of it. So yeah,
Have you designed like have you started designing like some so you were talking Cliff, you were talking about how you're going to do memory safety, but have you tried to design that?
I have not.
Okay.
I feel like it's doable with the typing analysis that I have, and looking at the kinds of types that would make sense for being used. I think it's entirely doable. And then it'll be very low annotations, and you get good usage patterns and no unsafe, unbounded, whatever, no undefined behavior. I think I have to go soon. I have people trying to reach me. Um, so I have to call it here pretty quick. Anyone else?
Yeah, my last thing, one of the things that I've been convinced of just by talking to people in this club is that it is valuable to have a difference between the types as the runtime sees them and the types as the code sees them. And I very well may have in my code a thing that looks to me as a mutable pointer, but the runtime has looked at it and compiled the code and go, oh, this thing is never actually mutated. I can treat it as immutable and do all the immutable things because I happen to have looked at your whole program and it's not mutable.
Yeah, right.
Or I've treated it as a potentially shareable pointer that could be returned up the stack,
Yeah.
but in fact, it never is and it never escapes. And in fact, I can call it a unique pointer and treat it with all the unique
Well,
pointer rules.
I'll say if it's not going to
Despite
go
the
up the
fact that you
stack,
never claimed it to be a unique pointer.
yeah, not go up stack, not
Yeah.
escape. I'm going to put it in register. There won't be any allocation.
But is this
And
really a
I just think there's a
runtime?
lot of value in the runtime understanding your types better than your code does.
But is this really a runtime type system and not more like just-in-time optimization
You mean
that
I
what I'm
may
don't understand the
provide
distinction there.
type feedback?
like? Yeah, I don't know what you're asking about.
You know, the JVM understands non-nullable types in a way that Java does not.
Right.
Oh, right. I remember, Cliff. If you ever design this language, like not the VM part, like in that language, and it does not allow like mutating, like if you try to get more than one references to an object, and I can't hold on to both of them at the same time, like that's what Rust does. It cannot. I will absolutely hate your program because that's my number one complaint. Rust makes my code look like ass. Like it's so garbage. Like that's my actual reason for not liking it. It just
Okay.
makes all my code look terrible.
It could be a fair complaint about it. I've heard other people complain about that too. Hilo does something along those lines where the rule is, I guess they have a
Really?
different rule. It might be different. Okay. All right. Anyone else here? Because these are all good questions for next go round too. All right. I'm done.
Yeah. See you
Cool.
all.
Thank you, everybody. And see people next week.